Hey guys, what's up? Welcome back to the classroom. It's Mr. Low, and today we are going to finish up on the part on ratio for this whole topic. All right. So before we proceed with the chapter, let's do a quick recap, shall we? Okay, let's move to the side. Okay. So we have learned in the previous video about this thing called ratios. Okay. So essentially, ratios is a comparison between two quantities, right? So for instance, the example that I quoted right at the start of the video, right? Let's say we are comparing the number of boys, right, is to number of girls. So this is the way that we can present a ratio, which is, yeah, as I said, it's a comparison between two different quantities. In this case, the two quantities are the number of boys compared to number of girls, right? Let's say in the class there are 25 boys and then there are 15 girls, right? So boys is to girls is 25 is to 15. But however, we also learned in the previous lesson, in the previous video, that we cannot simply leave our answers as such. We need to reduce the ratio to the simplest form. In this case, I realized that I can divide both sides by 5, right, to give me 5 is to 3. Now, actually, what does this mean? What does this 5 is to 3 means? Right, if you think about it, it actually means that for every 3 girls that I pick up from the class, I'm able to find 5 boys. Right, 5 is to 3. Or I can say it the other way around, right? Every 5 boys that are in the class, there are 3 girls. Right, so yeah, this is presenting your ratio in the simplest form. All right, on the other hand, we also learned that there's another way to present ratios, but remember they are not the same, which is in the form of a fraction. So the same ratio can be written in another form, boys over girls. Right, technically it shouldn't be boys over girls, it should be kind of like number of boys over number of girls, yeah? Number of girls, right? Something like this, okay? Equals to, well, it's the same, 25 over 15. Now you know that this is a fraction. We should also leave it to the simplest form. So you can see that, I'm dividing both sides by 5. In this case, for the fraction, we can do the usual cancelling thing, right? So number of boys over number of girls takes the ratio of 5 over 3, right? They kind of mean the same thing, right? These two ways of representing ratio, but you do not write 5 is to 3 equals to 5 over 3. This is absolutely wrong. All right. Now we also learned that in order to compare two quantities, they must have the same units. Right, same units. Now what do I mean by that? Recall the question on the length. All right, the length. So let's say I have quantity A being 1.0 meters and quantity B being 50 cm. Now notice that the units are completely different. One is in meters, one is in cm, even though both are length quantities. They're both lengths. So if I want to, sorry, I should use equal sign, yeah? If not, you would think that is a ratio. No. So now I want to find the ratio of A is to B. All right. Now, before I do that, because of the difference in the units, I have to convert one to the other so that I have the same units. So let me choose to convert A from meters to cm. Of course, again, you can choose to convert B from cm to meters. It doesn't matter, right? So here 1.0 meters, okay, is equals to how many cm? Remember, I must have the units cm over here. If not, I will make a very bad mathematical mistake. Yeah, equals to 100 cm. Yeah, as you know, 1 meters is 100 cm. So now, yes, I can now compare cm to cm. No problem. So I'm going to write down the ratio. A is to B equals to, 100 is to 50. Now, do I need to write the units in the ratio? No, answer is no, because they both have the same units. So there's no need to write. Anyways, now again, we don't leave our answers as 100 is to 50. Instead, if you notice, I can divide both sides by 50. Yeah, so 50 divided by 50 divided by 50 as well to give me 2:1. And that's it. All right. So of course we also dealt with fractions in a ratio. So for instance, 5/2 is to 1/3. So how are we going to simplify this? Right? If you're not too sure about this, um, refer to the previous video again, the part 1 of this series on chapter 7. Right? We also dealt with things like 0.25 is to 0.4. How do we, in the end, turn it into a nice ratio, 25 is to 4? Right? This is again, you refer back to the previous video to recap if you're not too sure. All right, so we're gonna move on to the next part of this series. Okay, it's called equivalent ratios. Okay, now let me give you a brief introduction about this thing called what do I mean by equivalent ratios? Yeah. Okay, so for instance, we have a ratio A is to B. Okay, we write for instance it's 5 is to 10. Yeah, 5 is to 10. Now we know that 5 is to 10 is also the same as 1 is to 2. Right, they're equivalent. So these two ratios, 5 is to 10 and 1 is to 2, they are equivalent ratios. Okay, because they're exactly they're really the same ratio. Okay, so how do I obtain the bottom ratio 1 is to 2 from 5 is to 10? Well, from here, we divide both sides by 5. Right, divided by 5. This is how we get the other one. But if I tell you I have a ratio 1 is to 2 and is equivalent to 5 is to something. Now, how do we find that something? Make a guess. All right. Now, you realize, we're doing the reverse thing, right? So let me highlight the semicolon here, so you can see very clearly which one is on the left hand side, which one is on the right hand side, and you have to pay special attention to which one you're referring to. Okay, so the semicolon is highlighted in yellow. Okay, let me compare, because for the ratio on the right hand side, the number to the right of the semicolon is unknown. We only have information from the one on the left hand side, right? And the one equivalent in the first ratio is the number 1. So how do I get 5 from 1? Well, I can multiply by 5, right? And this is what we do as the opposite of dividing by 5 in this green color example, right? So from the first ratio on the left hand side to the second equivalent ratio on the right hand side of the equal sign, I've multiplied the 1 by 5. So in order to get my question mark, what should I do to the 2? The 2 is the number to the right hand side of this semicolon here. Well, I should also multiply by 5, isn't it? Okay, because at the top, we divided both by the same number 5. So to reverse the process, we multiply both sides by 5, and without using your brain too much, you should also get the answer 10. All right, so this is how we find out a particular unknown number in an equivalent ratio. Okay, now that's just now I mentioned that we must be careful of the position of the number. For instance, this one is to the left hand side of the semicolon, because you might compare it to the wrong number. Let's take a look again. For the same ratio 1 is to 2, let's say now I say it's equals to something is to 20. Okay, now in this case it's a bit special. Now the unknown is to the left hand side of this semicolon over here. So which number are we going to compare it to? Is it 1 or 2? All right, if you chose the number 1, then you're absolutely right. Okay, you should be comparing it to the number 1 on the ratio on the left hand side. Yeah, so no choice, we are going to compare 2 and 20. Okay, so how do I get 20 from 2? Well, multiply by 10. So likewise, the unknown should be obtained by 1 times 10. That gives us 10. Alright, so this is how we find equivalent ratio. I hope that is clear enough. Okay, so let's go straight into the examples here. Okay, in part A, we have 2 is to 7 is equivalent to 10 is to unknown. Alright, so again, I said take note of the position of the semicolon, right? Sorry, the colon in the two ratios. Okay, so if you pay attention, then you know that 2 should be compared to the number 10. I multiplied 2 by 5 to give me 10. So therefore, the unknown, the blank here should be obtained by multiplying 7 by 5 to give me 35. All right, so I hope this is clear. Okay, so likewise for part B. Okay, this time part B, the blank is on the left hand side, which we actually compare it to the number 5. So 3 should be compared to 12. Okay, and you get the relationship times 4. Okay, so I'm going to zoom out here to show you the answers for part C and part D. All right, okay, so if you understood this process, go ahead and pause the video and finish these practice questions on your own. Okay, you realize that it's a whole string of equals. That means at the end of the day, this ratio here is equivalent to 4 is to 12. They're equivalent. Yeah, quite interesting, right? But the idea is the same, right? So try to fill in the blanks, and we'll discuss when we meet in class. Okay, moving on. Now, remember we said that ratios, usually we deal with two different quantities, A is to B. Sometimes we deal with three quantities, A is to B is to C. Right, so we are comparing three quantities. For us, for our level, at most three quantities. Okay, so in this part of the lesson, we are expressing two or more, essentially 2 or 3 ratios as a single ratio. Okay, if you don't understand what this is about, let's look at an example over here. Okay, in the first example, the ratio to yellow to green books, block, sorry, is 3 is to 2. Okay, so it'll be nice to write down, yellow is to green, right? 3 is to 2. And the ratio of green to red blocks is 1 is to 2. So again, I'm going to write it down. Green is to red. Okay, green is to red is 1 is to 2. Find the ratio of yellow to green to red. Very interesting. So this is what we're tasked to find: yellow to green to red. Okay, so we are combining all the three colors into a single ratio. Oh, of course, there's a part 2 here, and hence, so when you read the question, please be careful. So there is a part A here. Find the ratio of y is to g is to r, and hence part B, the ratio of yellow is to red. So here we are tasked to find in part B, yellow is to red. Okay. Now, before I proceed to do the question, please take note of the word hence. Okay, when you see this word hence, please highlight or circle whatever. Hence tells you that in order to do part B, I must use information from part A. Okay, so to do part B, I repeat myself again, to do part B, you must use the result or your answer, final answer from part A. If you are going to start all over again and use another method, that means you're not even using your answer from part A, you will not get a single mark, even if your answer is correct. Please pay attention to this word hence. It's very important. All right, I'll show you what it means by hence. Okay. Now, so let's get into part A first. Let's go into part A. Okay, so let's write down the information that we have in the question. We have y is to g is equals to 3 is to 2. This is one thing that we have. We also have another information. G is to r, pardon me. G is to r is 1 is to 2. Now, do you realize that I purposefully wrote the second ratio slightly to the right? What am I trying to do here? I'm actually trying to align the green color to the green color. Notice that the green color blocks, we're referring to the same items. Okay, just that there are different ratios because they are compared to yellow and compared to red separately. Okay, the same number of green blocks, again, the same number of green blocks when compared to yellow and compared to red separately, they give us two different ratios at the end. But you know that the number of green blocks is the same, in both the ratios. It should be the same. Okay, because we are talking about the same pile of green blocks to begin with. So how do I deal with this? We have a number 2 here and a number 1 here, but we know that they must be the same number at the end of the day, right? In terms of number of blocks. So what can we do? Well, we can do this for the bottom ratio, 1 is to 2. I'm going to attempt to turn this number 1 here into the same number as the other ratio, which is 2. So how can I do that? I can do so by multiplying both sides by 2. Alright, don't blink your eyes. 1 becomes 2 and 2 becomes 4, right? Now, what do you realize here? Now, this 2 and this 2, okay, they take the same ratio or the same number here. So now, because green, for the green part, right, the green blocks, we now have the same ratio 2, we can immediately go ahead and compare everything in one ratio. If you don't understand, just try to follow up. Okay, so yellow is to green is to red now is simply 3 is to 2 is to 4. Did you realize that? Do you understand what I'm trying to do here? This 3 is to 2 is obtained from here. While on the other hand, this 2 is to 4 is obtained here. When I have a common 2 in the middle for green. Only then I can combine the two ratios separately into one single ratio. I hope that is clear enough. If not, we can go through another example another time. All right. So now, let's look at part B. Hence. Hence means you must use. So this is end of part A. I'm moving on to part B. Hence means again you must use the result from part A, which is this one. You must use this result, right? So since so I'm just gonna quote the results from the previous part. Y is to G is to R equals to 3 is to 2 is to 4. We are tasked to find what is Y is to R. Actually, we're done really, right? Y is to R is simply 3 is to 4. Okay, so therefore Y is to R equals to 3 is to 4, and we are done. Okay, so we can directly compare Y and R again because we have a common ratio of 2 for green. Previously, before we manipulate the ratio 1 over here to turn it into 2, we cannot immediately compare. For instance, 3 is to 2. We cannot just compare like this. Okay, because the ratio for the green, that number here is not the same. Alright, only by turning it into a common 2, then we can immediately compare 3 is to 4. All right. Okay, so this is one example. Hopefully it is clear to you. Let's move on here. All right. So besides presenting itself this kind of problem of combining two separate ratios into one single ratio of three quantities, in a word problem, this is the more straightforward and standard type of question. Okay, so let's take a look. A is to B is 2 is to 3. So immediately I write it down. A is to B, pardon. A is to B is 2 is to 3. And B is to C is 3 is to 5. So notice that, my common quantity here is my B, right? So I'm going to write B aligning to the top. B is to C equals to 3 is to 5. Okay, right? So I've aligned my B in line like this. Okay, now the next thing I have to check is, are these two numbers the same? Yeah, both are 3. So we are done. There's no need to change anything. We can immediately combine. A is to B is to C. Therefore, it goes to 2 is to 3 is to 5. Okay, and we're done. That's it. Because the other question asks for A is to B is to C, right? So this case is simple because B, they both take the same ratio. We can immediately combine. And we can even compare A and B. 2 is to, sorry, compare A and C. 2 is to 5, right? Next one. In this case, yeah, let's take a look again. A is to B, 3 is to 4. B is to C, 2 is to 5. So again, the common item here is B, but you realize that the ratio is not the same. Okay, 3 is to 2. So no choice, we have to make them the same. Okay, we'll turn them into the same number for the ratio. Well, again, let's write down. A is to B is 3 is to 4, and B is to C is, oh, sorry, my bad. The number we're looking at is 4 over here, yeah? Not the 3, because the 3 is representing the ratio of A. Okay, so B is to C is 2 is to 5. Okay, so now, again, step 1, I have aligned the B in one straight line. But you notice that, oh God, it's not the same number. So what can I do? Well, I can try to turn this 2 into 4. How? How am I going to do it? By multiplying both sides by 2. All right, and that gives me 4 is to 10. Now, great, we have the same number 4, right, for our quantity, our common quantity B. Can you realize that? Right? So immediately, therefore, we can combine the ratio A is to B is to C is 3 is to 4 is to 10. And we're done. Right? So this is combining again two separate ratios. These two separate ratios into one single ratio. All right. Moving on. Okay, so this is another real life problem. Dividing a quantity in a given ratio. Okay, let's look at the problem straight away. Shirley baked 3 cakes of 3 different sizes. Okay, 3 different cakes of 3 different sizes. The ratio of the small to medium to large, I'm supposing is the size, yeah. Okay, so small is to medium is to large is 1 is to 2 is to 3. 1 is to 2 is to 3. So let me write down the information straight away. S is to M is to L. I'm assuming it's the size is 1 is to 2 is to 3. Yeah. Okay, so again, good practice here. Okay. Write down the information by the side as early as you read it. Okay. Now, she would like to sell them at a total price of 120. That means I'm gonna sell all the 3 cakes. Sorry, more like Shirley is gonna sell all the 3 cakes, and she wants to receive a total of $120. Okay, so I'm gonna sell. She's gonna sell the small, the medium, and the large, and she wants to totally collect 120. Yeah. So so maybe I can write it down. Okay, price of small plus price of M plus price of large is 120. Okay, this is what this piece of information is trying to tell us. Okay, but what is the price of each cake? Oh, as you can imagine, the bigger the cake, um, the the pricier is gonna be, right? The more I'm gonna charge my customer, yeah. Or more like she is gonna charge the customer. All right. So indeed, as we read the question further, the cakes are priced according to their size proportionally. Okay, so this line actually tells us, right? The larger the cake, the higher the price. Okay, larger the cake, higher the price. So they're asking what is the price of each cake. So you're asking for price of small, medium, and large separately. Yeah. Okay. So we know that the bigger the cake, the higher the price is going to charge. She's going to charge, and when we add up all the prices, it is $120. So quite interesting, right? Okay, so in this case, let me show you how it's to be done. Okay, so let me write down the information again. S is to M is to L is 1 is to 2 is to 3. Now this 1 is to 2 is to 3 can be the ratio of the size, can also be the ratio of what? The price, isn't it? Right? This can be the ratio of the price because, well, the larger cake, we're gonna sell it. She's gonna sell it more expensive. Okay. So how many units of, so assuming that we don't know what is the price of the small cake, right? Because if we know the price of the small cake, we can immediately tell that the price of the medium cake is 2 times and the price of the large cake is 3 times, right? So in this case, we can think in terms of units. We can think in terms of algebra as well. Okay, let me try to think in terms of unit. Yeah. Okay. So let the price. I'm doing a bit of a combination of algebra and units idea here. Actually, they are the same. Okay. Let the price of the small cake be 1 unit. Can you see that? Right, 1 unit. Right. If that's the case, then price of medium cake should be 2 units. Yeah. And lastly, the price of large cake should be 3 units. Okay, so this is what we obtain from the first information. S is to M is to L is 1 is to 3. We obtain this bunch of information. Now what else do we know? This one. Okay, we can make use of this to continue on with the question. So if we're going to sell all the 3 cakes, rather if she is going to sell all the 3 cakes, right, she will have received a total of 1 unit plus 2 units plus 3 units should be equals to $120. So how many units are there in total? 6 units, yeah. Therefore, 6 units is $120, and therefore 1 unit represents 20 bucks. So again, what does 1 unit mean in our working? 1 unit represents the price of the small cake. So we are done. So price of small cake is $20, right? And the price of the medium cake is, well, 2 units, yeah, 2 units. So it is 20 times 2, 40. And the price of the large cake is 3 units, and therefore it is $60, yeah. Or rather, I should write down the full working. 20 times 3, that gives me 60. So how do I know my answer is correct? I can check 20 plus 40 plus 60, total is $120. Check, no problem. So that's it. Okay, so from this example, you can see that um when we have a ratio 1:2:3, essentially it's like comparing a number of units. Yeah, I could equivalently draw like a model thing, the price, so this is 1 unit, medium must be 2, and large must be 3, in the way that you're familiar with, and they add up to $120. All right, so you can see it like this, but of course this is no longer relevant, not recommended that you do this. Please do it the proper way, the ratio way. Okay. Okay, last example for the day. Okay, a certain shoe shop offer 3 brands of shoes for sale. Okay, the ratio of A is to B is 2:3. So again, I'm going to highlight and write down the information immediately. So here I write A is to B is 2:3. Again, I have to remind you of the interpretation of a ratio. What do we mean by 2:3? Does it mean that, the shop only has 2 pairs of brand A shoes and only 3 pairs of brand B shoes? Clearly not, right? It could be 20 pairs and 30 pairs. It can be 200 pairs and 300 pairs. We don't know. But no matter what the number is, for example, if we have 200 pairs of A and 300 pairs of B, the ratio will end up to be 2:3. So we don't know exactly how many pairs there are, but we do know the ratio, yeah? All right, next piece of information, B is to C is 4:5. Okay. All right. So what is the ratio of the brands? A is to B is to C. So this is the typical question that we have been doing over here, right? We are given 2 different ratios. We are told to combine the 2 separate ratios into one single ratio. So let's do it immediately. Okay, part A, we have A is to B is 2:3, while B is to C is 4:5. So again, I align my B, the 2 ratios together, so we can see very clearly. All right, now we run into some trouble because I see that this is 3 and this is 4. I can't transform 3 into 4 or 4 into 3. Can I do something about it? Can I somehow turn, how do I then turn both the numbers into the same number? Okay, if you think hard enough, the number 12 should pop out in your mind. Okay, what do I mean by that? Let me erase the bottom half, okay, so that you can see clearly. Now, 2:3, I'm bearing in mind, okay, I want to turn this 3 into 12. Why? Because 12 is the lowest common multiple of 3 and 4. Okay, so if I were to turn this number into 12, what skill are we using here? We are actually using the skill, pardon me, of equivalent ratios over here. Okay, if you don't remember, please refer back to this part. We are using the idea of equivalent ratios. So for 3, I want to turn it into 12. I multiply both sides by 4. And I should get the equivalent ratio of 8 is to 12 for A is to B. Okay, now I have achieved what I want. I've turned 3 into 12. Let me do so for the next ratio, B is to C, which is 4 is to 5. Okay, again, I want to turn this number 4 here into 12 so that, I have the same number for comparison. Right? Okay, so how do I do that? 4 to turn into 12, if you're quick enough, multiply both sides by 3, and we get the ratio 15, 12 is to 15. Can you see that now? I can now compare. Okay, the B is over here. I have 12 and 12. Now I can compare. Now I can combine. So let's go ahead and do it. So A is to B is to C is now. Remember, I have to take this ratio here and this ratio here, right? Because that's when B takes 12 units. Yeah. So it's 8 is to 12 is to 15. And we're done. Okay, that's the ratio of A is to B is to C. But again, does it mean that the shop only has 8 pairs of A, 12 pairs of B, and 15 pairs of C? No, need not be, right? Again, it can be 80 is to 120 is to 150, 150. We don't know, right? We don't have enough information to tell us how many exact pairs there are in the shop, unless the question gives it to us. So let's take a look. Is there, in part B, is there any information? Yes, there is. Immediately, the question give it to us. There are exactly 24 pairs of brand A, and we are tasked to find, how many B and C. Sorry, how many? Oh, C only. How many pairs of C were there in the shop? Okay, so now we are given exactly 24 pairs. So let's take a look. In part B, we recap the ratio. A is to B is to C is 8 is to 12 is to 15. Now, given the ratio now, we know that this 8 units here represents 24 pairs. Okay, so we can write in terms of units. 8 units can represent 24 pairs. Now we are asked to find brand C. Brand C has 15 units. So how many pairs is that? It's 24 over 8 times 15. That gives us 45 pairs. And we're done. Okay, of course, it will be good to write a concluding statement. Therefore, there are 45 pairs of brand C shoes in the shop. Yeah. Okay. So again, this let me repeat myself again, so it's very naggy. This ratio just tells us a ratio. It does not tell us exactly how many pairs of shoes there are for each brand until we are given the information that, okay, 8 units now represent 24 pairs. Only then we can tell exactly how many pairs of B and C there are in the shop. Okay, so in question C, we are asked to find how many pairs of shoes were offered for sale, meaning how many shoes are there, how many pairs of shoes are there all together. Okay, so we know the drill. So since 8 units represent 24 pairs, now how many units of shoes are there altogether? 8 plus 12 plus 15, that gives us 35. So 35 units, 24 over 8 times 35. That gives us 105 pairs. Right? And our concluding statement is there are 105 pairs of shoes um for sale, right? Yeah, for sale. Okay. In case you're a bit wondering where the 35 comes from, 35 comes from adding all this up, yeah? 8 plus 12 plus 15. Okay, so there are a total of 105 pairs. Alright, so I hope you find this interesting and useful. Okay, if you understood this, please go ahead and complete the homework here. Okay, to every single question. Unfortunately, I can't cancel any questions. Okay, so we will discuss this next Monday, which is which date is it? Is the 29th. Yeah, okay, 29th June 2020. Right. So I'll see you back in class with this homework. Right. I hope you understood today's lesson. And this concludes the first part of the chapter, which is ratios. All right. I'll see you back in class. Take care.